Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 26 from the Smith Organic Chemistry textbook. And in this problem is sort of the opposite of some problems that we've seen already in this chapter, where previously we were given monomers or sets of monomers and asked to predict what the polymer would be. In this instance, we're actually given polymers and asked to sort of work backwards and determine what the monomer or monomers would be. And so we can start with A, and the best way to do this, I think, is to try to identify exactly what you have and how it could be broken into pieces. So what we see is nitrile groups, and then we see, 3 carbons between each carbon with a nitrile group. And so the nitrile groups obviously are going to be 1 unit, and then probably the carbons with nothing are going to be another unit. So if we think about how can we break this into pieces, if we draw a line here, and then we draw a line here, and then a line here, and then draw out, what each of those would look like in pieces, or actually, so we could actually do this. We could do this another way too. One thing that I've advocated in solving other problems is to draw your monomers out and then erase the double bonds and instead connect the carbons. And so if you were to do the reverse of that in this instance, you would get your monomers back. So if we go ahead and erase those bonds that we drew lines through previously, it would be these bonds are gone. And we need to replace them by putting double bonds, on the carbons that we erased them from. So, and then actually, I suppose if we're trying to be consistent, we would erase these as well. And so when you do that, it becomes, readily apparent exactly what your monomers are. And so the monomers here are these two. And so that's the answer to A. And so we can, oh dear. Okay, there we go. Sorry, computer froze for a second. So there's the answer to A. And then we can take a look at B. And with B, it's a little different. So if we were to look at this, our pieces are these pieces. And so if we want to break bonds or think about where the connections are in here, it would be this. These ester bonds are the bonds that are going to need to break. And so thinking about thinking about monomers that we've seen and how this would work, it becomes apparent that what we need to make this polymer is something like this. So sequences of 4 carbons with a carboxylic acid on one end and a hydroxy group on the other. So the hydroxy group is going to be the nucleophile, and we'll attack the carbonyl here. We'll get the tetrahedral intermediate, and then this hydroxy group will get kicked out. And so that's how we form these polyester bonds. So there's actually only one monomer here, and it's this guy that I've drawn here. And so that's the way to approach problems like this. Think about what bonds need to be broken, and then break them and see what you have, and that's your monomers. And so that's the answer to chapter 31, problem number 26.